Hello, everyone. Welcome back. So, today I'm going to be talking about the rates of change in functions, in the rational functions specifically. So, the good news about this is it's not much different from rates of change that we already know. Here it asks us to determine the average rate of change for this function on the interval from -5 to -3. So, our average rate of change in general, we know, is f of -3 minus f of -5 over -3 minus -5, right? So that's how we would normally do this. And this is no exception here. We're going to do this the exact same way. So what is f of -3 in this case? Well, that's going to be 1 over -3 plus 6, which is a third. What about f of -5? Well, that's going to be 1 over -5 plus 6, which is just going to be 1. So now if we plug that in, we're going to get a third minus 1 on the top, and on the bottom we'll get -3 plus 5, which is 2. So here we're going to get, well, what's a third minus 1? Well, that's going to be -2/3 over 2, which is the same as -1/3, right? 2/3 divided by 2 is 1/3. So our final answer would just be -1/3. Good. So yeah, so same thing as we're used to doing with our average rate of change from previous sessions and also even previous courses for some people as well. Yeah, same sort of thing, just with a new type of function. Okay, let's do this one. This one says estimate the instantaneous rate of change of this function. Okay, so with instantaneous rate of change, we're going to do it to within a tenth. So what I'm going to do for the instantaneous rate of change, estimate, is that's going to be f of 4.1 minus f of 3.9 over 4.1 minus 3.9. So what is f of 4.1? Well, that's going to be 3 over 4.1 minus 6. And what's that going to be? That would be 3 divided by 1.9. So that's going to be -1.58. Okay, and what about 3.9? Well, that's going to be 3 over 3.9 minus 6. That's going to be about -1.43. Okay, so now let's plug those values in and see what we get. So -1.58 minus -1.43 over 0.2, well, that's going to be, let's see, positive, that minus 1.58 divided by 0.2 is going to give us about 0.75 approximately, or I guess -0.76 approximately. So our instantaneous rate of change is about -0.76. Okay, let's do example 3 next. Example 3 says, the snowshoe hare population is a newly created conservation area, can be predicted over this model, P of t equals 50 plus 2,500 t squared over 25 plus t squared, where P represents the population size and T is the time in years since the opening of the conservation area. Estimate the instantaneous rate of change of the hare population after 2 years, include the units. Okay, so for this one, for the instantaneous rate of change, we are going to do it for 2, right? So we're going to find P of 2.1 and P of 1.9 and use those as our values just for this estimate. Okay, so what is P of 2.1? Actually, let's give ourselves more room to find that. That's going to be 50 plus 2,500 times 2.1 squared over 25 plus 2.1 squared. So what's that going to be? Well, 2.1 squared is 4.41 times 2,500 is 11,025. And then on the bottom here, we have 2.1 squared plus 25 is 29.41. So that's going to be equal to, let's see, 50 plus 11,025 divided by 29.41 is 376.57 approximately. So there we go. So that's what we're going to have for P of 2.1. Now what about P of 1.9? Well, that's going to be 50. Oh, wait. My apologies. Okay, it's 50 added at the very end. Okay, so I did this slightly incorrectly here. No worries, let's fix that. Okay, so we have 2.1 squared plus 25, so that's 29.41. Okay, so we have 11,025 divided by 29.41, and then we add 50. So it's actually going to be 424.87. Okay, so that's going to be our actual answer there. All right. Now what about this one? It's going to be 50 plus 2,500 times 1.9 squared over 25 plus 1.9 squared. So that's going to be equal to 50 plus, well, let's see, 1.9 squared times 2,500 is 9,025. And then we have 1.9 times 1.9 plus 25, which is 28.61. So 9,025 divided by 28.61. And then we're going to add 50 at the end, and we're going to get 365.45. So there we go. There it is. All right. Okay. So now let's plug those numbers in finally. So back to our original question that we were asking, 424.87 minus 365.45 over 0.2. So that's 424.87 minus 365.45 divided by 0.2 is 297.1. So therefore, the rate of change is increasing by 297 hairs per year after 2 years. So I'm going to write a quick conclusion statement here, as this is a word problem. Therefore, the hair population is increasing by 297.1 hairs per year after 2 years. So that's our instantaneous rate of change. Well, approximately, I should say. That's our approximate instantaneous rate of change, because technically we haven't learned the calculus method for finding the instantaneous rate of change. But for as far as this course is concerned, this is the best way we know how to do it, and this will get you the full mark. Okay, let's do 2 more examples here. All right. After you eat something that contains sugar, the pH or acid level in your mouth changes. This can be modeled by this function. where L is the pH level and M is the number of minutes that have elapsed since eating. Estimate the instantaneous rate of change at 3 minutes to 3 decimal places and include units. Okay, all right, so let's do it. Let's estimate it to 3 decimal places. Okay, so our instantaneous rate of change at 3 minutes is going to be about, let's see, L of 3.1 minus L of 2.9 over 3.1 minus 2.9. All right, so what's L of 3.1? It would be minus 20.4 times 3.1 over 3.1 squared plus 36. Okay, and let's see what that's equal to. All right, so 20.4 times 3.1. Okay, so that's negative 63.24 over, let's see, 3.1 times 3.1 plus 36. That's 45.61. Divided by 45.61. It's equal to negative 1.39. Or wait, they said it's 3 decimal places, so 387. Okay. And then L 2.9, that's going to be negative 20.4 times 2.9 over 2.9 squared plus 36. Okay, so that's going to be 2.9 times negative 20.4, so negative 59.16 over 2.9 squared plus 36, 44.41, which is going to be, let's see, divide by, that's going to be negative 1.332. Okay, so now you can finally actually plug some of these values in. So we're going to get negative 1.387 minus negative 1.332 over 0.2. Okay, so that's going to be, minus 1.387 divided by 0.2. Okay, that's going to be 0.274. So therefore, the pH level the pH level is decreasing at a rate of 0.274 levels per minute after 3 minutes. All right, awesome. Okay, and let's do one last example here. It says, as you get farther from the Earth's surface, gravity has less effect on you. For this reason, you actually weigh less at higher altitudes. An astronaut who weighs 85 kilograms can use the function WH. W of H equals 2 times 85 over H plus 2. Well, that's interesting. Really? 2 times 85 on the top there? They couldn't have simplified that further? Anyway, okay. To find their weight, W in kilograms at a height of H meters in thousands above the sea level, above the Earth's surface. Estimate the instantaneous rate of change of an astronaut's weight when they are 5,000 meters above the sea level. Include units. So H is meters in thousands. So we're actually going to do 5, right? We're going to find W of 5.1 and W 4.9. Okay. So for For the instantaneous rate of change, it's going to be equal to about W 5.1 minus W of 4.9 over 5.1 minus 4.9. Okay, so what's W of 5.1? That's going to be, well, 2 times 85. They actually could have just simplified that there actually. That's going to be 170 over 7.1, which is 23.94. And then here we have W of 4.9. So that's going to be 170 over 6.9. That's going to be 24.64. Which is negative 0.7 over 0.2, which is negative 3.5 approximately. All right, so therefore, the astronaut's weight is decreasing by 3.5 kilograms per 1,000 meters at 5,000 meters above sea level. Awesome. All right. Well, that's it for today. Good work today, everybody, and I will see everybody for the next class. Bye, everyone.